Now I am going to present a robust analysis on 3D video processing through the deep learning technique, and this presentation is part of digital video processing. And now this is my presentation outline: motivation, related work, implemented method, discussion, conclusion, and references. First, the motivation part. The main motivation behind this work is the autonomous driving car or the self-driving car. It is now there are a lot of research are going on in this topic. We all know about the Tesla car, which are automated car. Now, how the automated car is going? Definitely, there have some mechanism how they work, how they see the picture and real-time picture, video, and how they made decision. Now, uh, I have to go or not. And for recovering the three-dimensional structure information from the monocular camera is significant for automated driving. And now going to the related work, there as I already mentioned that there are a lot of work have been done in this area, and the research already going on, and how the camera take the picture, or they predict. There are some way, um, supervised way, unsupervised way, semi-supervised way, and depth estimation, and uh, from the monocular video, and ego estimation. And since the depth estimation is long standard problem in the vision of robotics, and numerous approaches involves stereo of the multiple view, and to the best a correlation ever structure model relation between the depth and Gaussian estimation also. And here we see a picture and of 3D geometry structure during the learning by model individual object motion, ego, and the screen estimation. Here first one, the depth and the ego motion estimation, and the uh, and the baseline method. Through the baseline method, it is seeing such like this. And in this paper, what they are demonstrate that the 3D object, here a man is standing or walking, the layer of the 3D object, the ego estimation and the depth estimation, and through they are processed, we see that a proposed method of the model, here we see the man is visible is better way from the previous one. And it is the self or the unsupervised depth estimation, a well-known issue of supervised learning, that it tremendous level training data is required, while it is way too vulnerable due to the noise from the environment and sensor itself. It contrasts a self-supervised way can capture ego motion and depth from the monocular video without any other sensor by. And this is another technique of the, it is also a deep learning technique, and in this technique the convolution neural network is addressed. Here, train a convolution neural network of unsupervised and the supervised depth cues achieve to state performance in single image depth prediction and supervised sparse and unsupervised stereo images and predict the depth map of an image. And here we illustrate the method of the semi-supervised deep learning and map prediction, map of the road map and roadside. In the first one, here in this, we see illustration of our illustration of deep learning residual decode arithmetic C1 to C3 and MP1, abbreviate of the convolution 1, convolution 2, first convolution, second convolution and third convolution, and then what is happened? The max pooling. Through the max pooling, it respectively and skip the connection from the corresponding encoder layer to the decode the facilitate the detailed depth map prediction. And after that, what is happening in this? It is the reschedule the block rest block k1 by n with the stride of s equal to 1. The reschedule the obtained from the 3 successive convolution, 1 to 3 successive convolution, and the reschedule has the same number of channel input. Okay. After that, we go through this. In this, it is we also can say that it is type 1 reschedule and it is type 2 reschedule. It is the block size is reschedule block k square, which ks square, which stride is s, and the reschedule is obtained from the 3 successive convolution, while the first convolution and applies stride s, and additionally convolution applied the same stride s project input of the number of channel. Okay, and in this we symmetric illustration of the unprojection reschedule block, symmetric way reschedule block. It unfolds the input by a factor and applies reschedule block, which reduce the number of channel by factor size. Okay, through this is the whole way how the deep learning process is work done. There are many techniques. Here they use the convolution, they use the max pooling, they use rescheduling, and in the next it is here in this figure of the input signal, the name of the image, but it is illustrate the a geometry consistency loss of the self-discover marks given two consecutive frame, one frame here, one another frame here, two consecutive frames, and this is IA and this is IB. Here first estimate the depth maps DA and DB, and relative to pose using the network, then get the warped DAB by converting DA to the 3D space, the projecting the image plane of IB using the PAB, and the finally here use the inconsistency between the DA to B and DB to I, interpolate the dB from interpolate from the dB as the geometrically consistency laws. Okay, and finally and this is the another unsupervised learning of the depth ego estimation picture. In this we see a training enable video clips and then the nearby views and its depth convolution and the nearby views, the depth convolution and the pose of the CNN. After that, in the discussion part, we now came here. This is a picture of table. Here some algorithm are given. This is a picture. The table picture is taken from my original report. Here the first in the first column the method and the years, then the training set, and after that the supervised manner and the main conclusion discussion. And here we see the depth and RGB training set are taken, most of them, and here supervised data, all are the supervised data, and in the conclusion of the summer the convolutional neural network use summer the multitasking technique. They are use multitasking means the some of use the hybrid process also, and then some are taken the CRF continuous mechanism, CRF hierarchical mechanism, CRF hierarchy plus multitasking. And to continue the discussion, because no ground truth is required during the training performance of unsupervised method, lag behind of supervised method. In supervised manner, the handcrafted feature and the first utilize the estimation, and the decided depth of the region instead of the estimation depth, and in unsupervised uh, it is a well-known issue the supervised learning is that termination level training data is required while it is too vulnerable due to the noise from the environment and sensor itself. It contrasts self-supervised OA can capture ego motion and depth estimation monocular. In general, think that the development of the monocular depth estimation will still focus on improving the accuracy, transferability, and real-time performance. In accuracy, the most of the previous work mainly focus on providing the proving the accuracy depth estimation by adopting new loss function or network frames as shown in table. There are several well-known network frameworks like LSTM, BAE, GAN have shown their effectiveness in improving the performance of depth estimation, and there are many development of the deep neural network trying the new network frameworks like 3D convolution, graph convolution, and attentional mechanism. It may get the satisfactory result, although unsupervised methods do not rely on ground truth during training. Their accuracy is far from the current most effective semi-supervised method. Uh, the more efficient is the geometric consistence. The proving the unsupervised method uh, may be a good detection. For transferability, the transferability refers the performance of same network on different camera, different scenario, and different dataset. The transferability of depth networks is increasing the attention. Most of the current methods are trained the tested on the same dataset, thereby achieving a satisfactory result. For the real-time performance, although a deeper network show outstanding performance, they require more computational time complete the estimation task, which is great challenge for the application. Now, in the conclusion, we can see that the uh, contribute of this growing area of research in the deep learning based monocular depth estimation, and we survey related works of the monocular depth estimation from the aspect of the training manner, including supervised, unsupervised, as well as the semi-supervised learning also, combining the application of the loss function and the framework. In the end, we also discuss the topics as well, the how it's work, and so there are still some challenges uh, that provide some valuable idea and the promising direction of the future research. And here there are some references that I used, and thank you. That's all.